that, was managing director at Accenture Federal Services, and I also had 25 years in the Navy. It's my pleasure to introduce our speaker, Amir Bagherpour. He's a managing director at Accenture Federal Services. He leads development of advanced analytics platforms and methods with applications in diplomacy, defense, and international development. His areas of research are disinformation, crisis and conflict forecasting, application of game theory and agent-based modeling for national security applications, and emerging technologies. He's got a really interesting career that spans academia, government service, as well as commercial from Accenture. So he served as a director of advanced analytics at the Department of State's Bureau of Conflict and Stabilization Operations, and later as the director of data analytics in the Office of the Secretary of State. Earlier in his career, he worked as an application engineer in the commercial space, where he designed motion control components for manufacturing automation processes. He has a PhD in political science with emphasis in methods from the Claremont Institute for Graduate Studies and an MBA from the University of California, Irvine. Welcome to Dr. Bagherpour.
Well, thank you, Jim. It's good to see you. Actually, when I started Accenture several years ago, Jim was my boss, and hadn't had a chance to connect with him in a while. So it was great to connect with him at this symposium. Good morning. My name's Amir Bagherpour, and today I'm going to be giving a practitioner talk about simulations for geopolitical forecasting and decision making. I'm going to be giving the view from really a practitioner standpoint in terms of how this stuff gets executed in context of decision makers, particularly in environments where you have a lot of stakeholders. And many of the decision makers, I would say most of the decision makers when it comes to geopolitics, are not technical people, and many are not data literate. But nonetheless, we have to come up with incentives and ways to make recommendations and implement capabilities where we could get better results in terms of decision making. So it's challenging to forecast or predict a wide variety of events systematically in geopolitics, given the nuances of each event. Limitations in data collection and explanatory requirements needed to persuade largely non-data literate decision makers makes this a very challenging task. And despite improvements in computing technology and exponential growth in data, much of the world's information remains uncaptured, particularly the type of information and context needed for making decisions in geopolitics. People seek better models and more data. However, there's trade-offs. For instance, in the case of the 2020 presidential elections in the United States, aggregate human judgment vis-a-vis prediction markets outperform polls and most complex statistical models derived from them. A historical assessment of the prediction markets versus polls pertaining to U.S. presidential elections dating back to the 1800s revealed market prices during the pre-poll era predicted presidential elections at least as well as polls have done following the introduction of the scientific survey. The study by Erickson and Leeson in 2012 revealed it's possible to evaluate the performance of prediction markets both before and after introduction of scientific polling. Surprisingly, markets predicted better without polls, partly because pre-poll markets were good at extracting essential information about electoral forces at work. Once polls were introduced, market prices mostly followed the polls, even when they erred dramatically, as they did in the famous 1948 election in the United States for the presidential elections, where it was called incorrectly and Gallup called it correctly. And you see here, like it's just one of the news articles that had come out around the 2020 elections, where they cited how predicted, which is one of the dominant prediction markets was set up by academics in Australia outperformed most of the poll-based forecasts. But on the flip side, prediction markets have an inherent flaw as well. For instance, take the recent failure in aggregate human judgment prediction market in missing the mark on the invasion of Ukraine. This is the publicly released estimate of the Good Judgment Project's professional super forecaster assessment 20 days prior to the invasion of Ukraine, stating an 82% probability that a Russian invasion of Ukraine will not take place. 12 days later and 8 days prior to the assessment, the super forecasters adjusted their aggregate forecast to only a 41% probability that a Russian invasion will not take place. In essence, reversing their estimate. From a practical decision-making standpoint, this incremental approach with massive swings in forecasting adjustments, such as the case of Ukraine I'm highlighting here, illustrates the limitations of aggregate judgment when it comes to decision-making in practical matters that require planning and some early warning. Being right on our forecasts and predictions are not as valuable when it comes to geopolitics if we cannot provide valid, explainable reasons to decision makers on why the events are likely to occur or why the events are going to go a certain direction. In the cases where prediction market forecasts are correct, analysts provided rationales that are difficult to falsify because they're essentially matching qualitative reasoning to the probability they assign from the judgment. This means that aggregate probabilities derived from human observers can result in spurious rationales for why things occur the way they do. And in this context, neither aggregate judgment nor statistical forecasting models alone have the explanatory power needed for making decisions pertaining to complex geopolitical problems such as conflict and crises. Today, I make the case for simulation and geopolitical forecasting. From a practical perspective, in geopolitics, very few decisions are made using statistical forecasting models alone. In fact, very few decisions are made using statistical forecasting at all. That's a problem. Questions such as how should we engage diplomatically? How can we resolve or mitigate a conflict? How should we respond to a crisis are limited in solving based on multi-stakeholder constraints. Stakeholders have varying degrees of preferences and influence and salience towards the issues. Therefore, to provide practical pathways to solving these problems or mitigating unsolvable ones, we have to understand these problems from stakeholders and group preferences while providing an explanation needed to persuade non-data literate decision makers. The agent-based simulation approach to forecasting is particularly appropriate in geopolitics. That's the case that I make, and based on my experience, what I found to be true. Because the explanatory value and the ability to test scenarios using stakeholders allows a level of flexibility for providing explanation and persuading decision makers in an empirically valid way. Obviously, we can test those scenarios in non-agent simulations as well, but in geopolitics, a focus on stakeholders and group constraints is paramount. Because if you try to find the optimal solution, but you're constrained by the varying positions of the stakeholders, that optimal solution is unattainable. Because in geopolitics, decisions are political, accounting for multi-stakeholder constraints lends itself to agent-based simulations, which are essential in part and stand apart from other forecasting approaches on these types of problems. Multi-stakeholder simulations incorporating formal deterministic rules allows us to test assumptions. We can then combine the testing of these assumptions with stochastic modeling, Monte Carlo methods, for instance, to account for error and exogenous factors not accounted for in the models. This yields greater potential for improving judgment and decision making in geopolitical decision making compared to event based or structural indicator based geopolitical statistical forecasting alone because of the simulation's design. Simulation is designed for flexibility and practicality in testing alternative futures and answering context-based questions through explicit adjustment of assumptions, conditions, and theoretical boundaries. For example, common questions posed by decision makers during international crises ranges from inquiry into which coalitions or actors pose the prospect of escalating violence to what pathways do we have to de-escalate the crisis. Answering these questions requires empirically replicable approaches to simulating the crises and assumptions in the questions. It requires exploring the scenarios to understand how decisions might yield different results. So how are decisions made today? As I touched on it earlier, in geopolitics, most decisions are still made with wisdom and anecdotal evidence. Under today's status quo, decision makers still rely on qualitative scenario exercises, commonly referred to as tabletop exercises. Although effective for planning purposes, these tabletop exercises are insufficient and remain difficult in providing a predictive value for anticipating the crisis outcomes or reliably answering context-based questions necessary for policymakers' understanding of a problem. Tabletop exercises present highly granular qualitative context, but no ability to test or falsify the assumed scenarios. Conditional questions are answered with extremely detailed responses and arguments, but there's no way of determining whether one argument is more plausible than the other. The solution requires the application of simulations, most relevantly the fusion of agent-based models for coalitions with structural simulations estimating impact of social, economic, and demographic conditions. Whether faced with executing an already determined policy or developing a new policy, decision-making in geopolitics is a deliberative process that requires answering these context-based questions by numerous stakeholders. And simulations, particularly agent-based models, enables answers to these in a replicable and falsifiable way. So scrutinizing a simulation as is a feature and not a bug. And in practical matters, when it comes to multi-stakeholder decision making, whether it's a national security, diplomacy, in international context, that is sometimes seen as a weakness. But the simulation's purpose is to establish the assumptions so that we can test those things. And despite the established benefits of agent-based simulations as an alternative to more commonly accepted forecasting approaches or qualitative judgment, there remains obstacles to wide-scale application of geopolitical decision-making. Most policymakers are accustomed to qualitatively detailed judgment of experts who view simulations oftentimes as a black box of magic. As articulated by Professor Phil Tetlock at Wharton, the richer the details, the easier it is to transport ourselves into the story. But if anything is a black box, it's the very qualitative judgment and opinions of functional specialists under the illusion of explanatory depth, as evident by the difficulty in falsifying often untested beliefs and assumptions. In contrast, the application of simulations allows analysts and policymakers to transparently reveal data inputs, initial conditions, and assumptions of the formal theory driving the outcome of the respective model. Through this transparency, simulations are open to a level of scrutiny typically not experienced by qualitative expert judgment. Once policymakers, analysts, and decision makers realize that scrutiny of a simulation serves as a transparent means to understanding a problem, the pathway to better decision making in geopolitics will be realized. So I'm going to go through a simple example of how this process kind of works. And And this example is is a crisis in territory Z. I'm going to provide a simple theoretical simulation of a non-specified hypothetical crisis and a simplified version of how this process is run. So territory Z, here's the scenario, or the example. Territory Z has been governed independently, but country X views the territory as part of its territory and is claimed to use force if necessary. As country X continues to assert itself, its ambitions to take territory Z is stated by the leader publicly by country X's leader. Tensions are rising. Country X has ramped up political and military pressure on the territory Z. Analysts fear the countries X and Y could go to war over territory Z. So, step one, we set up the parameter and the assumption. In this initial step, we establish the assumptions that are many that go into the simulation. In this simple example, we developed 4 scenarios outlined above using parameters capturing political, economic, and military factors affecting the decision calculus of the various stakeholders and groups. Major stakeholders include the president of country X, the military of country X, the president of territory Z, the president of country Y, the allies of country Y, and the allies of country X. The scenario parameters help calculate the estimated payoffs of various stakeholders seeking to achieve various optimal scenario pathways. These are the establishment of the assumptions going into the simulation. Now remember, the key is not to pinpoint validity of every single assumption, but rather the flexibility that allows us to change assumptions to explore alternative scenario pathways. So in geopolitical decision making, when you're in the room, right, somebody gives their opinion and you ask them, what are your assumptions based on this opinion? 9 out of 10 won't even know what an assumption is in practice, right? They're going to be like, well, they'll give you like a historical perspective and they'll give you qualitative insight, right? This takes it one step forward by saying, okay, if this is our assumptions, right, then this is the logical conclusion towards these various types of scenarios that we're looking at. And then we could state the assumption up front. Not just the assumption in terms of the specific scenario, but the assumptions in terms of like the logic in a transparent way. And the discussion of what those particular assumptions are is part of the decision-making process. So in step 2, simulated payoffs of the agents. Below is the table of estimated utility payoff score for major groups or stakeholders involved in the crisis. The scenario closest to current reality, status quo, is indexed at 0. It's basic game theory. Any payoff score greater than 0 are better option than the status quo, while any payoff score less than 0 is worse than the status quo. Using a game theory-based payoff generator, in this instance, these groups and stakeholder payoffs are capture the preferences across the parameters defined in the issue setup. The model, through the model, you then sift through the full combination of possible payoff scores to identify the true payoff that corresponds to each scenario outcome. When accounting for aggregate influence of the various stakeholders and economic, political, and military factors affecting their decision calculus, the results reveal that country X, in this example, likely prefers a non-kinetic military response on territory Z. However, this may be difficult to achieve given country Y and country Z's response capabilities would likely impose significant costs onto country X following the prospective non-kinetic response. So step 3, estimating probability by Monte Carlo simulations. The chart depicts the results from Monte Carlo simulations. In this example, Monte Carlo simulations were applied to test how the outputs react to random generated inputs over many trials. The simulations were conducted across 2,000 runs with 100% variance probability. We applied a uniform distribution. In each simulated alternative future, we randomized the parameter options and subparameters that we stated in the assumptions and the inputs. And the results revealed that there's a 55% likelihood President X will seek to escalate beyond the status quo. His or her most favorite option is a kinetic response according to Monte Carlo simulations. However, he or she will be constrained due to country Y and territory Z's deterrent capabilities. According to Monte Carlo simulations, country Y and allies will seek to maintain the status quo. Country X allies will also seek to maintain the status quo and dissuade country X from escalating. And then last, you run further scenarios. And here, we run more scenarios by combining Monte Carlo simulations with game theory payoffs. Aggregate probability of a Y escalation is 47% compared to 52% likelihood of status quo or de-escalation. So again, this is just a simple exercise, example of how we apply simulation and establishing the assumptions, testing those particular assumptions, and then running through the logical process with decision makers. The point isn't that this is the perfect model. The point is that we can transparently establish assumptions and be able to explain those assumptions and what the logical conclusion goes to given those particular assumptions in a transparent way that's explainable to decision makers. And this is the end of my talk, and thank you for having me, and I look forward to the discussion.
Anybody have questions?
Would you mind going back to the step one slide? Thank you. I just wanted to look over it again. I didn't have a question in particular, but
Sure.
Do you think these will be posted as well?
oh, awesome. Okay.
They were last year. So another hand. Go ahead.
You mentioned at the beginning one of the challenges in talking with some of your customers who might not have much of a technical background. Can you elaborate on that a bit more? How do you overcome convincing them that the numbers you put in front of them, they can make decisions based on those rather than the sort of gut instinct?
That's a great question. Well, one of the ways that you convince them, right, is you say, given these are the assumptions, based on these assumptions, this is the direction that things are going according to this model. And where you're always, where we get the most, where we have the most success is when the customer disagrees with your assumptions or the inputs. Because that's an opportunity to say, let's adjust those assumptions and let's adjust those inputs and let's see what the logical conclusion is. Several years ago, there was a international conflict in the Middle East, and we showed some models that showed that a particular government's not going to collapse, right? The way that the decision makers thought that it would, and the client disagreed, like high, it was a very high level person, and we said, okay, what are your assumptions and what are the inputs that you want to test? And we tested the assumptions, like we cut the adversary's capabilities in the model by 50%. We tripled allied efforts on that particular country, and it showed that the government still persisted, right? And it resulted in secondary factors such as rise of terrorism, et cetera. And it changed the views of some decision makers, some significant decision makers. And so the examination of those inputs and that flexibility really creates opportunities to be able to walk through with decision makers on what the assumptions are and what those pathways are if you take it to its logical conclusion. I'll give one other example. So in the challenge in this area is that is about incentives, right? Unlike, let's say, Wall Street, right? If you are right on something in this field as a practitioner and you are divergent, you get punished, right? Where the entire like arbitrage system in like Wall Street is, being divergent and being right. There's many stories of people that were right, that whose careers were affected and were punished. So being right it doesn't mean anything sometimes, right? Unless you have the ability to be able to validly persuade. And the simulation, right, the model is a third person in the room, right? So this isn't according to like my opinion. This isn't according to like Jim's opinion. This is the model indicates that this, shows this based on these assumptions. And simulations enable us to answer questions in a way that are honest, right, and transparent, and can counter, right, the things that people are sometimes being forced, because people try to see what they want to believe. Like we jokingly say, it's supposed to be evidence-based policy making, but sometimes it's the opposite, right? It's policy-based evidence making, right? If people have a groupthink going. So I'll give you one last example, a true thing that happened many years ago. A senior official said, "I want you to model out, right, a collapse of X regime in February," right? We'd like to see that, right? And then so, like, well, what do you do? Do you not respond to this individual, right, who's a very high-ranking official, right? Risk getting punished, right? Or do you like accommodate that person and then risk ruining your reputation? And with simulation, right, it's particularly useful to answer those types of questions. So we built a model that showed what it would take, right, for that thing to happen within that time-bound period. And we said, well, these are the things that would happen under this kind of scenario. This is what happens. And the decision maker said, or one of the decision makers said, "That's impossible. That's not going to happen. We can't do that." And I was like, "Well, then it's not going to happen, right?" But you asked, what are the conditions in which this would happen? It would happen under these particular conditions, and that moves the needle from where things are today, in my opinion. And so governments, countries have intelligence apparatus, right? And there's like red lines, so the intelligence folks don't get messed with as much. But many decisions are made outside of intelligence. Like they have limitations in decision making, right? Foreign affairs, foreign policy, it's a political process. And so introducing these types of capabilities in decision making, I think takes us from where we, where we're not in a systematic way. There's been progress made, but by and large, despite all this stuff that you're seeing in the propaganda and the hype in terms of technology and AI and all these things, in this area, right, on issues related to conflict and diplomacy and all these things, many of the highest level decisions are still made qualitatively.
Thanks for the talk. I'm sorry if I missed this, but I'm curious about how you're measuring the parameters relative to each other, because it's not the measurement itself, it's how they relate to each other. And how are you measuring the accuracy of your results if it's all so if you could go into that a little bit more.
Right. So the measurement of the parameters are twofold. One, we're measuring the parameters based on a formal modeling assumption sometimes, right? Using like foundational, like game theory logic in this case, right? And then we are accounting for error, right, by running Monte Carlo simulations and seeing how robust or how sensitive a particular variable might be or a scenario might be. What was your other question?
I think you answered it.
First, thank you very much for the presentation. Very impressive. I'm gonna ask the question you ask a little bit different. In agent-based modeling, one big thing is you build a big model, complicated, but most of the work is how you validate. Like, I have this model, there are parameters, those parameters can be different, some of them are, there are a lot of uncertainty, and you try to validate with many, many different, methodologies. I don't, since what you're doing is very strategic and a lot of parameters, I guess, are not visible to you or even visible for intelligence people, how you validate that this model that we have built is accurate enough. It's not going to be accurate, but accurate enough for decision maker or reliable in terms of.
Yeah, that's a good question, and that's your second question. I just remember. Okay, so from a practitioner standpoint, okay, and this is about incentives. The question that you asked, right? Just as important as the model development is the incentives that you set up within the organization for people to be incentivized and motivated to tell the truth. Okay, and so beyond the model itself, you have to set up incentive mechanisms for measuring and incentivizing accuracy, right? From a practical standpoint on delivery with clients on stuff like this, we set up a tracking system, right, for measuring accuracy, precision, and recall, right? But our clients, some of our clients in this, I'm sorry, I'm saying it like our clients are like idiots, and they're not. I'm saying it's not. That's not the. You have very smart clients out there, but in decision making and like Geopolitical, the stuff you see on the news, like they're not thinking with numbers. It's because and it's not because they're idiots. It's these things are hard to measure, and it's a lot of assumptions, right? There's a lot of assumptions that go into it, and then that's not a perfect solution in itself, but. From a practitioner standpoint, the way that we set up the incentives on stuff like this is we look at accuracy and precision and then the level of specificity. And then we set up a tracking mechanism in which we can track, right, truly like out of sample, right? Like did the simulation display the direction that things were going off the baseline within the time frame that it was estimated? And how accurate was the track record when you look at the issue and then the variety of different issues as well?
Thank you. Then, from practitioner point of view, I would say since they keep paying you, that you're reliable enough for them. And I think that's the way to look at that from practitioner perspective. The second question is, a lot of things are behavioral, like say in Russia conflict, Putin as a person, if it was another person, he would do different things. How you account for behavioral aspect, given a lot of things are not observable for you, and how you account for changes, like new developments, like what happened, Wagner people, we didn't even expect that's going to happen, new stakeholders. Are you enough flexible to adjust because agent-based models building is a very complicated and lengthy process. How flexible are you introducing new stakeholders, adding new assumptions, and running it and helping policymakers?
So just like any forecast, you have to make adjustments, and then so you set up a consistent time frame for when you make routine adjustments, and then you have to make adjustments when the situation dictates that you make this adjustment, right? So for example, you make an agent-based model, and then the central, this has happened many times, right? In conflict in particular, the key decision maker disappeared from the battlefield because they were killed, or there was a coup, or these things happened, right? So when that happens, you have to adjust the model, but also you run scenarios. And there's systematic ways that you could run the scenario through like a reverse auto solve, right? Where you try to look at like pathways, under what pathways does, scenario Y or Z occur? What's the optimal pathway, et cetera? Or you do very targeted things in which, it's the analysts that are imagining like what would happen, right? So, I mean, that's very common. There's, what would happen if Vladimir Putin wasn't the leader of Russia today, right? What would happen if Zelensky wasn't the leader of Russia? What would happen if Vladimir Putin's influence was reduced by, significant amount? So you have to adjust these things. These things are not perfect, but it's the explanatory value. And then, just like in all other types of forecasting, there's a trade-off between the precision and depth of your forecast and the accuracy. You want a very precise, very accurate, highly detailed, right? But I'll tell you, like in geopolitics and international relations, highly precise, pinpoint accuracy, like forecasts and stuff, are very challenging, and and oftentimes we get very precise answers that are highly inaccurate. So kind of like it's not extremely scientific what I'm about to say, but you want to be moderately detailed, right? So that you could get a direction that things are going, and that's going to be more valid and accurate than something that's like highly granular and very precise, right? And then you're just getting yourself into a lot of trouble there and stuff. So, but at the same time, like, the scenario simulations are really important because it gives us a way to falsify it. And people that are experts, qualitative analysts, they're experts at saying things that are non-falsifiable and saying things that keeps them out of trouble. Where this, like you say, well, what do you think is going to happen? And then they'll give you great detail and say, well, on the left hand, it could go this way, and on the right hand, and on the third hand, and on the between hand, right? And there's no way, right, of making a judgment on in a measurable or systematic way on what's like the better decision. And oftentimes what happens, the person that makes that wins on the argument is the one that tells like a better story, right? Versus look at like what like the model says, right? And there's psychological and cognitive biases for the decision maker. So for example, like it's very interesting, like people can say crazy things, right? As long as they say it with like a bureaucratic, like monotone, like voice, right? Like they'll just like say, like you're like in a meeting and then you're just like, I can't believe this guy said what he said, right? And everybody's like nodding their head because he sounds responsible, right? They sound reasonable, right? But if you remove that cognitive bias and then you try to kind of like look at it in kind of a cold-blooded way, like a model, it serves as a mechanism for counteracting those types of biases.
Thank you.
Yes.
I want to come back to your point I really liked about models as a way of making assumptions explicit and pointing to logical relationships and so forth. And also then the ability to trigger questions, to address questions, what if we change this and so forth. But it raises the question in my mind, what, in your experience, what's the appetite of decision makers for repeated iteration? Does it also require that you have a tool that is literally quick enough that it's in the room with you and you can play out things in real time as opposed to getting back to them in a week or a month or whatever? So just some thoughts on that.
Well, it depends. It depends on the customer, right? But in most cases, the customer wants things to be iterative, right, and to be updated as close to real time as possible. These approaches are done anywhere from strategic level direction to complex negotiations. I've been in the room in complex negotiations with the Secretary of State, right, and special envoys, in the room where they're talking about their positions on a negotiation, and then we've had teams that go and like input like the positions and then try to understand how the negotiation's taking place, like what the pathways are for that. Applied this stuff to basing agreements, right? Arms resolution agreements, peace negotiations, and so for complex negotiations, these things are used, but the reality is that like the person that's running and thinking about this stuff, like using game theory or simulation, is still not right at the apex of like the food chain, right? The person that's leading it is this person's an expert on this armed group, right? And so it's really difficult in the status quo kind of environment in reality to be at the top of the ladder. But there are some sophisticated clients out there that do that. And oftentimes these things are most readily used on the second or third iteration after something fails, right? And so, once it's reached a point where where collectively people have decided that we need to look at fresh perspectives in terms of resolving intractable crises. These things start to get used more. And what we're trying to do is we're trying to say, well, let's try to incorporate these processes before it gets there and stuff. And so progress has been made, right? It is being used more frequently, but there's definitely a lot of work to be done. And that's why I'm skeptical, like when people talk about like AI and all these things, like we use AI like on many applications, but I'll tell you, like I've never been in a room where somebody says we're gonna go with that because the computer said yes. It's like people in this field refute basic trend. Like you have arguments like, look, it's getting worse, right? It's going this way. And then, you'll have a discussion on whether the trend is getting worse, right? And it's like a basic trend. Like, look, the line's going up, right? So that's what you have to kind of deal with. And simulations really bring a very transparent ability to be able to do that in this environment.
So this slide that we're on indicates like the depth that you have to have in order to set this up, right? You have to have a scenario, you have to have some potential kind of major positions, and then you have a bunch of parameters or assumptions going into it. When something new like what happened last weekend with the Wagner Group happens, how quickly does it, if you got tasked, could you turn around a new simulation to answer questions about that scenario?
Well, if you have the right team and workflow set up, I mean, you could update it in 30 minutes.
Okay.
And then so the generative AI large language models, there's a lot of potential to this because the most difficult part of constructing a model is the establishment of the assumptions and the parameters. Like, what are the scenarios? What are the factors driving that? And to do that right off the baseline, sometimes it takes days, right? And a lot of deliberation. Some of it qualitative. It's difficult to measure some of the some of the assumptions, right? There's a way that that we could control for error, but it definitely has its limitations. And with generative AI and prompt engineering, you could ask the question, and now it'll generate in 1 second the scenarios, the factors, the stakeholders, the estimated positions of the stakeholders in 1 second, right? Now, is it accurate? No, right? But it's doing it in 1 second, right? And then so if you use it appropriately to establish your parameters, and then have the analysts involved, right, adjust those things and QC it, the potential is really tremendous. Matt?
Question, Amir. So I read some research by Tetlock recently where he was saying that a lot of these situations, the subject matter expert tends to, let's say, inflate the probability that an event will happen because it's their area and they want to bring more budget to it. So am I correct to say that because you're considering all scenarios, it kind of tempers those probabilities to be a little more realistic, to not give the self-importance
That's
of
right.
the expert?
Yeah, so this process, like, what it does is, it really reveals who's an expert and what their biases are, and then so in our experience, the people that oftentimes become most averse to this are people that are have deep expertise on one thing but don't know any other thing, right? Or people that are, not really experts. Like, we were doing I'll just say this is several years ago, right? We were doing a forecast simulation on like in Russia, right? And then everybody's like, go talk to this guy. He's the expert on what's going on there, right? And then so we went and like interviewed him on like getting the positions of like the stakeholders, and there was no nuance. It's like, what's this guy's position? He's at 100. He's at 100. He's at 100. It's like, man, everybody wants to like this in Russia wants to to use nuclear weapons, right? Or like and they're like, yeah. And I was like, there's nobody, right? There's no nuance. And he's like, no, right? And you basically realize that it's not an expert, right? Being an expert, on these types of things, just qualitatively means like who the stakeholders are, you have an understanding of like what their stated positions are, and the way that you counter that bias is you do pooled judgment, right? So that's why there's a lot of promise in combining prediction markets with simulations, right? But those have their biases too. So the model is just a simplified version of the world, right? So but from a strategic standpoint, right, we need more models to simplify things, because what a strategy means, you're going to do certain things and not do other things, right? And so having a way to consistently systematize that, right, allows you to break down that strategic decision-making process in a way that's difficult using other ways.
Thank you.
Yes.
It just brings me to think that administrations who think themselves as being right and not looking at alternatives and positions are not going to use something that's going to give them different alternatives on a situation, versus if you have people in an administration that represent the last person that you spoke with, they're not going to come to you to ask for what the alternatives would be, and so it forces them further to the outskirts rather than.
Well, okay, so I'll say, like, as in the consulting business,
Yeah.
We have a lot of clients, right, that want that want you to agree with them, right? I mean, at a certain point, like, name a consultant that's there for a long time, right, that is always disagreeing with their client, right? So simulation is really useful because you're basically removing your, say, this isn't from me, this is from like a simulation, but also like if you want to use the simulation to execute a certain policy, you can increase the chances of executing that policy, right? So you establish the baseline and you say, look, if we had to estimate the direction that things are headed, this is the direction that things are headed. And the client will say, well, I don't agree with that direction. I want it to go a different direction, right? And that's where the value of the simulation is. The simulation's value isn't just to establish the baseline. It's how do we achieve the intended policy outcome, and we can use simulation to solve those particular pathways. except in instances where the policy is just absurd, you know? And then, that sets a different type of parameter. But it's not, it's not that bad. I'm not that pessimistic, right? You know, most of the time, it doesn't get to that level of extreme absurd.
Because you have career staffers mostly.
Well, no, you have like you have an entire entire bureaucracy, right? But it's but point well taken. But it's about better models. It's about better data. Simulation is very helpful, but in practice, just as important as the simulation, it's the incentives. It's the incentives. So how do we set up reward systems where people are incentivized to tell the truth, right? Because it's a trade-off between oftentimes in reality your long-term reputation and the immediate relief that you get from pressure from people to give a conclusion that they've already made, you know. Yes.
Can you give an example of one of these incentives, like anecdotally or with a model you've worked with in the past?
So for example, like we set up a tracking system where we track the baseline estimation of like what we say, right? And then and then internally we'll set up like mini competition on like what's our accuracy rate, how well are we doing, and then we try to publish internally when things are right and when things are off, right? And then we track it. And if you have a long-standing project and you're basically showing like the accuracy and how things are progressing, oftentimes people are less abrasive against something that you put forward because they're like, these guys are tracking like accuracy, and so you set up those incentive systems to counteract pressure from doing, like, it's not like policymakers. Nobody's going to get up in the morning and say I have horns and I'm lying, right? People believe in their stuff, People believe in things, right? Especially if you come from things from a rigid ideological standpoint, right? Everything could be a hammer and like a nail and stuff. But if you set up the incentive system in which you're saying, hey, the baseline is, and there's nothing wrong with wanting to change the direction of it, right? But as long as we're honest, saying, hey, this is the likely direction things are going, and these are the things that we could do to change that direction to get the outcome that we want achieved. That's totally legit. Yes.
Speaking of incentives, have you seen or you talk to them about your thoughts on what role anonymity in forecasts make? Like if someone wants to have a hot take, but they don't want people to know that it is actually what I think. Like, is there people? What do you think?
Like an anonymous suggestion box.
Like people are more likely to tell the truth when they vote being anonymous versus like peer pressure type thing. Is that something that you guys think about, or is that an influential thing?
So if we're doing like, if we're doing something that's like a larger sample, right? So if we're trying to like put like what a population thinks about something, and the stuff that I like is on the simulation stuff, like putting in a collective agent for a subpopulation, right? But in terms of the analysts and the people that are producing it, I haven't really thought about like anonymity, but from a practical standpoint, like there's a you just need to document, right? You need to, just like you need to cite your resources, you got to cite like who's saying or who did the particular work to be able to if you have questions for replication, all those things, you need to have the documentation to go back to the person to understand why they interpreted it or why they, modeled something a certain way.
I think we're at the end of the time. We're supposed to go to a coffee break next, so thanks for attending.
Well, thank you. Thanks for the opportunity to speak, because I know like this is like you guys are like hardcore forecasters and stuff. and all the stuff that we do is kind of based on what we learned from our knowledge of academia and the amazing research that is produced out there. So thank you. It's a real honor to have the opportunity to speak.
Norma said hi.
Yeah. I mentioned this energy thing.
Yeah.
You guys forecast.
Yeah.
How are you? Hey, nice to meet you. Leila. Oh,
Yeah, you did.
Oh, yeah.
Like I didn't even know science, so it's really cool to know there are people like you in the background helping with some of those decision making.
Maybe I will.
Thank you. Nice meeting you.
Yeah, same here. I'm not an expert.
The most useful.
Oh, okay.
So
Okay, great.
we don't have good data.
Yeah.
We rely on judgments, and I have done the backwards. We want everyone on track.
There's a lot of me though that's kind of
You
inside.
have to test this.
Oh, really? Are you working on HIV?
Well, I used to for a while, and
Okay.
then contraceptives.
So one of my biggest clients is SGAC,
Okay.
right? So Global AIDS Coordinator.
Yes.
So
USAID.
yeah. And PEPFAR.
Yep.
Yeah.
That's where I started my career. I did almost all the antiretrovirals work
Oh, wow.
at the beginning. And created a tool for it and helped countries figure out how to use it. Yeah, so that's when Ethiopia was like, we want this many people on antiretrovirals. I was like, well, the validity rate is so
Yeah,
low.
I've got two
So
ready.
you have to take millions to get enough positive people to have that target goal, unless you're really directing to the sex workers or identifying the high risk groups. And so they were like, oh, okay, well we can't do that. It's interesting.
Changing the data.
This is my second year at this conference. Regardless of what topic area you're in, it's almost always the same way. For me, it's really fascinating.
Great. Here, let me give you my
You
card.
don't have a
Forecasting, so.
Yeah. Sure. And then are you in the DC area?
I am.
Yeah, just shoot me an email. I'm around.
All right.
Thank
Nice to
you.
meet you.
Some part like this
Amir Bagherpour.
applies to marketing.
Oh, okay. I work with them.
No, yeah, thanks.
Good, thanks.
We are going to now is my presentation.
Oh,
so
yours presentation,
yeah,
okay.
yes, it's, just 20 minutes.
Thanks, I got you. Yep. Hey. Hey, alright. I'll introduce you. Did we ever meet in person before, Jim?
I think we may have met last year.
Oh, last year.
Oxford?
Yeah, I was in Oxford.
Yeah.
Did you come over there, Dan?
Yes.
Oh, yeah, he did too. This is my PhD student. It's kind of
Hey,
weird. He's graduating in less than a year, right?
Yeah.